Push share and follow for more.
Good day, my fans out there. I remain Dr. D.I. June, your chemistry lecturer on social media. My last lecture was on how to determine the end point of an acid-base reaction, which is that was called titration. And in that place I told you that this is practical experience that students ought to know before they finish secondary school. But because many did not go through the normal channel, registered in miracle schools, miracle centers, and obtained their credits in chemistry, physics, biology, and go to the university. But this practical aspect were not experienced by them, and they need to know it. And I told about two particular indicators we are using in volumetric analysis. Because acid and base, they are colorless solutions. So it is this endpoint, which is change in color, that enables us to know that the two substances have completely reacted. Now, if you are using methyl orange, as I said at that time, if you pipette 20 cm cube or 25 cm cube of the base in a conical flask, it is colorless, just white. So by the time you put 3 drops of methyl orange, the color changes yellowish. As you run the acid against it, at a point, the color changes to pink. That pink color shows that the reaction is complete. Salt and water is formed. The two elements have neutralized themselves, but you must know the volume of the acid used. If you are using phenolphthalein, as you pipette the 25 cm cube of the base, if you put 2 or 3 drops of phenolphthalein, the color of the base in the conical flask will look pink already. But when you run the acid against it, when it comes to a complete reaction, you see that the color, that pink color, turns to colorless. That indicates that the acid and base have neutralized themselves or each other. So, but today I will discuss about meaning and importance of IUPAC nomenclature. IUPAC. Say the body, IUPAC. The I stands for international. The U stands for union. The P stands for pure. And then the A stands for applied. And the C stands for chemistry. So it is figured as international union of pure and applied chemistry. That is the meaning of IUPAC. The word nomenclature means naming. Now, before IUPAC nomenclature, we were having the trivial names. That was the old names of naming chemical compounds. Now, NHNO3, the old name is called nitric acid. Nitric acid. But the IUPAC nomenclature is trioxo nitrate 5 acid. Now, why is IUPAC nomenclature important? You see, it was a body of chemists who came together and decided to give names to chemical compounds. One, IUPAC nomenclature tells us the number of elements present in the given chemical compound. 2, it tells us the combining power of the element, that was the original number of the element, specifically present in that compound. 3, the number of atoms of the elements that are present. Now let's see some of these ones on the board here. Now this first one, which is called nitric acid in the old name, it is now called trioxo nitrate 5 acid. NO3 is a nitrate ion. It's a nitrate cation. So when there's no hydrogen atom attached to it, this thing cannot be called an acid anymore. So it is the presence of the hydrogen that makes it an acid. Otherwise, ordinarily NO3 minus is a nitrate 5 radical. So The old name does not tell us how many elements that are there, but IUPAC tells us. Now, triazoonate 5 acid. That's what acid means. Hydrogen is attached to it. And then trioxo, 3 oxygen atoms. Nitrate 5. Nitrogen is exhibiting the power of 5 in this reaction. Now, H2SO4. The old name is called sulfuric acid. But IUPAC call it tetraoxygen sulfate 6 acid. So, apart from the 6 acid is mentioned, we know the hydrogen is involved. Now, the power of sulfur in this combination is 6. And we have 4 atoms of oxygen. So, tetra means 4. So, IUPAC nomenclature tells us the number of atoms of elements present, how many elements are present, the combining power of a particular element present in that chemical compound. Now look at this one now. Ca bracket opens, OH bracket close 2. Now the OH that is bracketed is an hydroxyl radical, and it carries a power of -. And calcium, the original number is +2. So here, -1 +2. So now when calcium and hydroxyl come together, there is exchange of the original numbers. 2 of calcium goes to hydroxyl. Hydroxyl has only 1, the 1 comes to calcium. So by exchange, the 2 that were of calcium goes to hydroxyl. That's why you see bracket open and close 2. That means the combined power of calcium is 2, now called calcium hydroxide or calcium 2 hydroxide. Calcium 2 that we mentioned means that the ON of calcium is 2 as it combined with hydroxyl radical. Now when it comes to this Na2SO4, this is called disodium tetraoxygen sulfate 6. Di means 2. So it tells us that there are 2 atoms of sodium in this chemical compound. Tetraoxygen sulfate. Then the tetra means there are 4 atoms of oxygen in this compound. Then sulfate 6 produces sulfur, that the combining power of sulfur in this compound is 6. And we calculate to get those original numbers. Now look at this one here. The old name is called carbonic acid. Carbonic acid. Because the CO3 is a carbonate radical. Now, the moment acid is mentioned, we know that hydrogen is involved. Now this is called triiosocarbonate 4 acid. Now, it now tells us that carbon is exhibiting the power of 4 in this chemical compound. So the IUPAC nomenclature tells us that in here we have 3 oxygen atoms, 1 carbon atom, 2 hydrogen atoms. And but the power of carbon in this reaction, as far as the original number is concerned, is 4. Now look at this other compound here, NaHCO3. The old name is called sodium hydrogen carbonate. That is a trivial name, sodium hydrogen carbonate. But when it comes to IUPAC nomenclature, it is called sodium hydrogen triosocarbonate 4. Sodium hydrogen triosocarbonate 4. Now look at this one here, KMnO4. We call it potassium tetraoxomanganate 7. So this manganese, in this compound, manganese is having ON, that is the original number of 7. And we have 3 elements in this compound. We have potassium, we have manganese, and we have oxygen. IUPAC nomenclature is telling us that here we have 4 oxygen atoms, 1 manganese atom, and then 1 potassium atom. But the combining power of manganese in this compound is 7. So it is named potassium tetraoxomanganate 7. Now, if you look at this other one here, CuSO4, the old name or